representative of Alatra Global Research Center. It's an international scientific organization who is dealing with current problems of our society. And one of these problems is studying micro and nanoplastics. I think the problem is very acute, and just imagine taking a deep breath right now. Right now in this room, we have really a lot of particles that are releasing from this furniture, that are released from this nice couple here, and we are surrounded by plastics everywhere, even from our clothes. So like for decades, we viewed plastics as a sort of eyesore, like bottles on the beach. But even those of us who are truly immersed in this problem, who are really taking care of the future of humanity, unfortunately may not realize the true scale of what is really hidden, because the real problem is in what we don't see.
Mm-hmm. Yes, and as you probably most of you here know, we have reached a point that micro and nanoplastics literally became integral part of us. Like Sasha mentioned, they are everywhere, in the air we breathe, in the food we eat, in the water we drink. And once it enters our bloodstream, it can circulate throughout the body, and it can actually get to all harmful organs. You can get into heart, into lungs, you can get into liver, kidneys, you can even cross placenta, and here it will obviously interact and cause some biological dysfunctions.
Yeah, to start the interaction, let's have a quick question for the audience. How many of you have really explored, studied the topic of MSD, micro and nanoplastic? Please raise your hand. I think that in our presentation, you will hear much more interesting information that you may not heard before.
And just to show the scale of the problem, because the microplastics are discussed quite extensively, but nanoplastics not as much. And what is micro, what is nano? Microplastics are larger than 1 micrometer and smaller than 5 millimeters. You can imagine them as large as an average cell, like red blood cell or bacterial size, and actually can be detected by regular microscopy. And nanoplastics are actually very, very tiny particles, smaller than 1 micrometer, and they can be as small as virus or even much smaller. And obviously cannot be detected by regular microscopy. We need like electron microscopy, Raman microscopy, and so on. So what is also important